Hello, good morning. This is a very beautiful exercise about the transmission of electricity from the North Africa to Europe. The context. Because the decreasing of fossil energy source and also because the increasing energy demand, we need to find other energy source to produce electricity. For example, in the desert, we produce in this area of the desert, they receive enough energy for 1 year of European consumption. The problem. You need to read, of course, the context. You need to give a unit of a specific electricity resistance, first exercise. Second exercise, to calculate the power lost. And third, calculate the relative power lost in percentage. And last question, why we take aluminium and not the copper? Because copper is better conductor of electricity. The unit, we use the first equation in the context. The resistance, you see the specific electricity, the length, and the area, the surface of a conductor. You change and you obtain the specific electricity resistance in ohm meter. We can check if it is correct. The resistance, the specific electric resistance, the length, and the area. If we change, we need to obtain that ohm is equal to ohm. We change and we obtain, if we calculate it, we can simplify it. M meter to meter square, it's simplified, and finally we have ohm equal ohm. If we want to calculate the power lost for 1,000 kilometer cable of aluminium with direct current, not alternative, direct current, we know the specific electricity resistance at 20 degrees, and we know the cross-section area, 321 millimeter square. We know the temperature coefficient, and we know that the current is 5,000 ampere. For a difference tension, electricity tension, about 500 kilovolt. And the operating temperature is 14 degrees. 40 degrees, not 14, 40 degrees, of course. We can find all the equation in the context. The power lost is the resistance multiplied by the current. We can calculate the resistance by this formula, this equation, and we can calculate the specific resistance at 40 degrees. If we do that, you see all the numbers. Don't forget, in this solution, you need to transform 1,000 kilometer to meter, and we need to transform the surface in meter square. You obtain this resistance, very low resistance. But if you calculate the power you lose with this very low resistance, use this formula, and you obtain an astronomical number, 235 megawatt loss. And if we want to calculate the percentage is very simple. We had to calculate the power loss in megawatt. If we calculate the power of transmission, the power transmission is the voltage multiplied by the intensity. Don't forget, the voltage is in volt. And in the exercise we speak about kilovolt. Kilovolt is 1,000 volt. and you obtain this number of megawatt, 2500 megawatt. The relative power loss is the power loss divided by the power transmitted, and you obtain 9.4%. Very important. But in reality, we need to take account of different factors, various factors. For example, the number of cable, the number of conductor in the cable. And if we take account of the various factors, in reality, we lose only 3.7%. More interesting than alternative current. Last question, why we take aluminum and not copper? In reality, copper is a better conductor than aluminum, but the density of the copper is very heavy. That's why we use aluminum. Okay, it's finished. Thank you, bye-bye.